I got the volume to work. That's good. Okay, and then I guess I have to share my screen now. Right. All right, so anyway, whatever I was saying, so it'll be on Zoom, so you could tune in from home if you want. I prefer that you're here. But basically, it's possible to. Anyway, the link is like here, the Zoom. I don't think you need the passcode. I think that'll just take you to the Zoom. And then I'm going to record those and I'll post them. I'll post them on YouTube and put them here, like a link to a YouTube video that will like those will also do like translations and stuff if you don't speak English. But I think most of the people in here speak English, but for grad students, it's kind of useful if they can just push a button and get a translation to whatever language, Hindi or whatever. So Chinese. So anyway, so I'll do that. But if I don't do the Zoom, you guys have to remind me to do the Zoom, because I just forgot. I had it all set up. I didn't want to have a lot of dead time at the beginning. Anyway, so then the deliverables like a homework a week. So like the homework is down here. There's a homework here. So this is about this book, The Waste-Free World. So the first section of this, like the linear versus circular stuff, is kind of like the fluff end of it. So this whole field has like the fluff end that really drove it at the beginning. So you had like the Earthwatch and all these environmental groups like drove this idea that we have to go to circular economy. And also people realized like Rumpke pile was getting bigger, something had to be done. And then the floating garbage in the ocean type thing, right? So there's kind of a variety of things that drove the field. But at this point, it's really, so like every of the big, large polyolefin companies like Dow, DuPont, LyondellBasell, which is the largest in the world in Cincinnati, and then Phillips Petroleum, all of them have at this point, they're purchasing kind of what were startup companies for recycled plastic, because they have to have a line of polyolefins that have like a blend with recycle, right? So like they call it mass-based economics. So you cut the virgin material, recycle, and it's like when you buy hamburger, right? So that doesn't come from one cow, and they raise lean ones and fat ones. They like take the fat, they take the meat, and they have a machine that mixes thousands of cows together to give you whatever you're eating. Same with the plastics. So that's one. So anyway, mass-based economics is the idea like you can include in the recycle stream some cuts of this, right? So anyway, so the first part, like there's this book. This guy, so this guy actually walks the line because he's pushing like the fluff end of it, but he's a businessman from New York City, and he ran the garbage business for New York City for a while, and then he went into like private to do recycling, like is making money off it. So basically he wrote a book called The Waste-Free World. It's all about plastics mostly. So that book, so there's two of these kind of fluff books in here, right? So, and they're easy reading. They're like reading a newspaper article. It isn't, I mean, so you can skim it. And I say like read some of it, but I mean, just like read it to the level of your interest in it. But definitely skim through all the pages I said and look at the pictures. Right. So, but if you want to read it, it might be interesting to read if you're interested in it. So anyway, that book is called Book here. And to get it, like it doesn't, it's PD missing the F at the end. So put the F on, it'll show up. So anyway, it's there. So you can read that book. And I say like, you could read the whole book if you want. It's a story he tells about, he goes through a little bit of the history of linear economy, like where it came from, why we ended up with like linear economy, where you do like petrochemical, make the monomers, make the polymer, make the product, then throw it away when you're done with using it, right? So it's like a linear. And cyclic is going to be like, take the polymer, depolymerize it, make monomer, feed it back in. That's one way to do it. Reuse the thing after, like take your water bottle and use it when you go hiking or something, refill it, or retread tires, things like that, right? So there's a lot of options for reuse, or get clothes from the what's the name of that thing? The place where you go to get used clothes, right? So yeah, Goodwill. Okay, thanks. Anyway, so go to Goodwill. So that's all part of this. So if you go to the Cincinnati like when the Cincinnati Recycle and Reuse comes in, so they're taking clothes, they're taking everything, like clothes hangers. So they have a whole stock of clothes hangers that they give away for free, things like that, you know. So basically, they reuse everything. So everything that comes in gets repurposed if it can, or reused, or there's also upcycling things, right? So there's a variety of things going on. Anyway, this book goes through that a little bit, you know, so you can kind of, from the perspective of a New York City sanitation head, you know, that went into the recycle business to make money. So he actually made kind of a fortune off doing this. So it's like there's a lot of money to be made in this thing too. That's one book. And then the book that the fluff book that's like the Bible of this area is like Made to Break from 2006. So it's an old, this is a new book. And this is an old book. Like this one was published like this year or something. And this book's kind of old, but it's really like crazy comprehensive. Like it goes back to the 1830s. And it talks about, there's some quotes in here where they go, it's a heat warning, so don't go outside. Anyway, so or else some guy with a gun's running up the stairs. So anyway, so he talks about like immigrants coming into New York again, like seeing all the waste, you know, like because we were so like land of plenty was like the theme of the 1800s, and like all the food and the coal and everything was just getting wasted. And the guy's coming off a boat from Germany or something. And he's like sweeping up the coal that they just kick out because they don't care. He says like from that sweeping, he could heat this whole apartment for like without buying anything, you know, because no one cared. Like there was so much stuff, you know. So and anyway, it starts 18 whatever, and then it goes on to like it's like a history book, you know. So I don't, you know, if you're interested, this is a pretty interesting thing to read. It's also like the famous kind of the Bible of circular economy, you know, like where things are going. So that's there. There's a bunch of other books here. Like, so each of these things is a book you can look at if you want that has something to do with this. Like just the more or less just the general idea, like circular versus single use, you know, kind of the framework of it, how it fits in and where it's going. But again, like it isn't just fluff, you know. It's like every business, like Sun Chemical. I'm trying to get the head of research at Sun Chemical, which is on Vine Street over here. So like the largest producer of pigments, which goes into plastics. And that's a big problem that you have. Try to recycle plastics and you mix a bunch of them together, you get gray because the colors all mixed. And you can't get the pigment out of plastic after that's why the park benches are all like gray, right? So anyway, so the pigment guys are really interested in making pigments that could be removed in processes to move. So everyone is doing this in industry. You guys have co-opted, you've probably seen it, you know. Basically, everyone is kind of interested in it. It's a number one area of expansion that they're looking at. It's driven a lot by like the EU, because the EU has strict rules on recycling. And then if you're doing business globally, say half your business in Europe, half in the US, then you're going to have to meet the European standards. And the US basically has to follow line, even though you don't have the laws here to cover it, except in California. And then California alone is like, I think it's 20% of the US population. They're basically driving through state regulations how to this kind of recycling business. So it's basically like California, the EU, and then China has pretty strict regulations too. This kind of odd mix of people that are driving it. In the end, it becomes like all the car makers. So the bumpers and things have to be in EU, they have to be like 25% recycled plastic, all the plastic parts in it. And then of the car that's produced, it all has to be able to be disassembled into components by EU standards so that they could all be potentially recycled, right? So that means every car, if you're going to sell Fords in Germany, so basically you're going to have to follow those rules. It means the US car is probably going to have the same stuff on it. So maybe we won't recycle it, but it could be recycled, you know? So it's driven partly by certain countries that have a big market share that are going to push this along. Anyway, so as far as the logistics here, let's see this thing. So anyway, weekly homework, and I set it up so as rotating groups of 4, except there's one extra student. So group 1 always has 5. And then it's like, the idea is like everyone contributes to every question, not that you split up the five. So it'll be like 5 questions, don't split it up. And we'll have 1 left if you do that. So, because it's 4 in a group, but except for the 1 group. So anyway, the idea is like everyone contributes to each question. And then there's going to be like some people that don't do anything. So just send me their thing, and then I'll move those people into a separate group. And it'll be like a no questions asked thing. Like they can't argue that there was something going on. I'll just automatically put them, and they'll just go into a group with other people that don't do anything. So it'll be like a don't do anything group that'll reach a maximum of like 3 or 4 people. And they'll just keep making more of those as people and it generally it'll be like 3 of those groups or something. It's not going to be like this. I mean, you know, I don't really care that much about the grading here, but basically I don't want people to get upset because they're doing all the work in the group and no one else is doing anything. Then like, you know, anyway, it's rotating groups. So you get eventually the people, hopefully it'll self-regulate itself. In the end, like everyone will do well in here. You know, it's not going to be like, it's not going to be hard to get an A in this class. You know, should be pretty easy. So then, all right. So, and a lot of you'll see like the questions are kind of fluffy, at least right now. And probably, I don't imagine I haven't written all the homework. So basically, but I don't imagine anything's going to be less fluffy. Like it's going to be just like general questions about things. What do you think about the world, whatever, you know? So it isn't going to be anything, but basically like this week, there's 70 pages of reading or something to do. But again, like if you don't want to do it, do like however you read fast. Or if you want to do it, read the whole book. You know, so it's up to you. What the book's there, you can read it, you know. So it's also in the library, I think. So you can probably get if you want a hard copy, but there's probably only 1 hard copy. So it's a problem. Everyone has to contribute. If they don't, then I'll put them in this kind of like Arlo Guthrie had that song, Alice's Restaurant. There's a group W bench. I don't know if you guys ever heard that song. It's about the Vietnam War, but anyway, the group W bench is where people like rapists and whatever went, and he had thrown away garbage, so he got to the group W bench. So I call those groups W group, you know, in memory of him. But anyway, so the group W bench, but so I think this 0 grade thing probably won't happen. Like I'll just give them the grade from that week as a gift, you know, whatever the group got, and then they can fend for themselves after. Usually when this happens, like people like perk up. All right, basically almost 90% of the people will like perk up and suddenly become very productive and get the highest grade in the class. It's really pretty strange. Like you put them on the spot and then like, it really shocked me a little bit because I thought, well, they're doing it because they can't handle it. No, it's just like they aren't doing it. So anyway, qualitative, and then the final homework would be like everyone does it. So I'll have to grade like 50 of them, you know, so it's like, otherwise it's like too much to grade. And then for the undergrads and for the grads, some kind of paper. So this is my plan. This may be modified by argument if you guys feel like it's too much for you to do or something. The idea is like, if you're doing research on some topic and there's some kind of circular aspect to it, you could do a literature search on that stuff, right? And then like kind of put together a paper that would have something like an abstract, introduction, body, conclusion. It's just like all the work, like find 30 papers or something on that subject of what you're doing research on that have to do with the circular economy. Hopefully plastics, but it doesn't have to be. Right. So, and then maybe you could publish that if you want. I mean, I'll look at it. So anyway, that's my vision of what the grad students could do, because they have to do something different than the undergrads. And then I think there's 8 grads. If this looks like too much, again, like it's debatable what you need to do. We have to do something like that. Then all right, then I notice like I don't know if I can get anyway, if you take like the homework, let's see, I didn't want to do that. I want to go to this guy. So if you go here, like it's pretty fluff questions. If you take like copy this and then copy this question, and then put it in Chat GPT, it gives you an A answer, like 100% A. It's really nice. It's got like boom, 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 boom. So you can do that, but just try to, I mean, for your own benefit. I mean, I did it. I did the whole quiz. It's like 100, more than an A. Like I give extra points. It's like nice, you know. And so it reads the book. It figures out the parts of the book. So I think you should. I mean, I think I would be tempted to just do that and see like, right, so that I don't have any idea. Like I looked at the book, I don't have the slightest idea to answer this because it's like 70 pages or something. So then just do that and it takes you exactly to the right part. Then just, you could write your own answer and compare it. You could look at this answer and then take it as like a framework, or at least you know what the answer is. And you could work it out, you know. It's actually a pretty good learning tool on how to make a coherent answer to something. But it tends to do like bullet point things when you ask it a question like this, which is a nice technique anyway. So I would use it to learn how to answer something coherently, because it's definitely coherent what it does. If you do that a few times, you realize there's an algorithm to it. So you can spot that algorithm pretty easily. Like first it restates the question, and then it says like, so you'll see there's an algorithm to how it's answering these things. It's really useful, I think, to figure out how to get a coherent answer to things instead of like rambling on about this and that like I do. You know, it's like basically computer is better, I think. But all right, so you're welcome to do that. But basically, it's good to have your own answer. And again, I don't really care that much about grades. So this is kind of like if you want to learn how to answer things coherently, I would use that as a tool to do it, because it can do better than you can do. It's like, I mean, I think it's pretty useful to use it. Sometimes it'll be like way off. Like sometimes the answer will be like so crazy, but most like 99% of the time it's perfect. Right? So anyway, so you can do that. I think I can't run my Chat GPT here, or I would do that. I can try, I guess, but I don't remember my password or anything. It's all in my phone. I think it won't work. I won't even try. Oh, you can do it and see how it goes. All right, so any questions on that business? That's kind of the setup of it. Hopefully we'll get people, you know, it's like late in the day. Hopefully we get some people showing up to class, but it'll be on Zoom. If we get more than like, it'd be nice to have more than like 10 people showing up, you know, something like that. So it's good, you know, and then anyway, so it'll be good. Having the people come in will give a different perspective too. So I think it'll be pretty useful. So anything about that, or yeah, the book I just showed you. Okay. Yeah, and put an F at the end of the link. Like go to the link that you clicked, and then go to the end and put an F, like PDF, and then it should load up. So all of them are like that. Everything in there is like that. All right, that's a good question. Anything else, you guys? All right, so anyway, I'll just start going through this first set of notes. So I'd like to cover this first thing, which is like the fluff stuff more or less this week, and then next week I think is like just plastics overview. So it'll be like a kind of a quick yeah, this is like just polymer science. If you took intro to polymer science, but whatever you need to know. This next week, there's actually a book called Plastics in the Circular Economy, which is the same name as this class. And the chapter 2 in that is like this thing. And it's a pretty good, you know, but it's kind of 100 pages or something. So I'll just zip through the highlights of it. I mean, you just need to know 80% of the recycled plastic is polyolefins. That's a shorter subject than like all the kinds of plastics in the world, you know. So anyway, so that should work out okay. And I'll spend, if it looks like it needs more time, I'll just spend more time on it. We don't need to get through all those caption areas, you know. We'll just see how it goes. But anyway, so these are all like a list of words. This is more or less from the book, that boring, I think the name of the guy's boring, but from the book from the New York City garbage person. Anyway, so there's a lot of words. I added a couple more. So it's like reuse is like go to Goodwill, get the shirt. Still is a good shirt, good enough, or it might even be better because it's old. Recycles this idea that you're gonna feed it back into the cycle. Recycle can mean a lot of different things, right? So it can be like repelletizing and then feeding it back in. For PET water bottles, you can depolymerize a polyester, and then you can make terephthalic acid and then repolymerize into PET. So some polymers only, basically at this point, only one, like PET can be depolymerized and then made into monomer and then remade into polymer. So, but there's dreams of doing this to a lot of other polymers. Like in polyethylene, you can do it. So there's a group at Cornell that's been doing it, but you need to use platinum catalyst. And it's not reusable, like you burn the platinum when you do it. Okay, so it's kind of a cost issue. It's like 60 cents a pound for virgin polyethylene, and platinum is like $300 a pound or something, right? So basically there's a big difference in price, so that a lot of these schemes for making monomer from polymer, and there's a lot of energy used in doing it. So if you burn more oil, see, there's all these trade-offs in it. It isn't so simple, right? And this, DuPont, I think, Eastman Chemical in Tennessee had a big plant just doing this, water bottles to monomer to polymer, right? And since the 1980s, they've been doing that. And basically they shut it down because it wasn't economical, right? So that the technologies, it depends on the economics too. It isn't just the technology, right? So it's kind of like, so that brings you to like the issue of wish cycle. So you have like recycle and you have wish cycle. That's when you take the saran wrap and you put it in the recycle bin. Like the saran wrap isn't going to be recycled. All it's going to do is gum up the Rumpke recycling. Right, so there's a lot of plastics that aren't. Oh, what did it say? I didn't read it. All right. Anyway, so there's a lot of plastics that just are totally useless, like the blister packages for the lettuce, whatever, can't be recycled. So if you put that in your recycle bin in Cincinnati, it can be recycled in where some places in where was it that I was? In Rhode Island, you can recycle blister packaging. So you can just put in a recycle bin. So it depends on the locality, like where certain, so you have to find out what Rumpke can recycle before you put it into the bin, because once it gets there, it has to be hand sorted out. So I mean, it's a huge problem. You see, if you can go to the tour, you'll see exactly what's going on. There are mountains of recycled stuff, goes onto a conveyor belt. There's a bunch of guys, like 15 bucks an hour, and they're pulling stuff out. Lithium-ion batteries are a really bad thing. The place burned down on Vine Street because of a lithium-ion battery. It's like if that gets in, so it's going to go into like grinding stuff, it'll blow up, you know, and then all of a sudden the entire place is torched. So all their investment's gone, and they have to rebuild it. So that actually happened in Vine Street here. But so anyway, so there's a lot of things you throw in. Anyway, there's a list online if you look at Rumpke recycling. So every locality has a different list of stuff. So it isn't universal, you know. Some things are universal, like polystyrene isn't recycled. I think it's number 6. So basically, some things just, even though, so you have number 6, it's printed on it, it shows a recycle symbol, so you throw it into your Rumpke thing, and then they have to hand pick out all the polystyrene stuff. Right, so it's a problem like with them. Jeff Schneider's coming, he'll mention like this kind of issue, I think, quite a bit. But anyway, so that's a wish cycle. You throw the polystyrene Scotch tape container into the recycle bin, and it just gums up the system. Recycle means you don't use any plastic. Like you don't actually use it, or you use a lot less. So you get your stuff in bulk, whatever, right? So you have your own reusable soap bottle, and you fill it up at some kind of co-op place, and like whatever. That's been around since at least the 1960s. This kind of pre-cycle thing. So a lot of these things have been around. They just haven't. It hasn't reached the crisis that it is right now. And I'll show you a plot of like how much stuff we're using, and it's exponentially increasing. So it's kind of like you can't ignore it anymore. Like it's kind of like reached the point where you can't ignore it, even though you'd like to. Reuse, recycle. So you can take things and repair them, and then reuse them. You can repurpose. So that's like when you I mean, the classic thing is you take a bottle and cut it and make a cup from it. Like, I don't know if you guys ever saw those kits. Like you take a wine bottle, you can cut it around and you make a glass cup. People do that. That's one kind of repurpose. I mean, there's a lot of different repurposing. Like we're doing something where we take polyethylene, put it into butane and put it in an autoclave, and then you can make like an insulation foam from it. So like a super insulation foam. So that's like repurposing. And that's also upcycling because the final product of that is worth more than the polyethylene that went into it. You're making an upcycle product and repurposing it. Recycles twice, and then downcycle is that you find some use for it, like a park bench. So you started out with a useful polyethylene thing, and then you turn it into a park bench, which is kind of like the lower grade, maybe like plastic lumber, is downcycling, more or less, But so anyway, there's a variety of kind of terms that are floating around in it. So it isn't just one subject about how to do this stuff. Anyway, so this is kind of a shocking thing that I found somewhere in a book. It's in the book on bioplastics. So they looked at 255 papers, or I guess 57 papers. There's 255 items in it. So the items are like a water bottles, so this is years of how long it would last in the environment. So you can imagine like we're producing like billions of these a year, and they're going to last like 700 years. And then basically that adds up, like all those billions just keep accumulating. Like, so it's a problem it's an exponential issue problem, So they give it for everything, like a foam cup, it's like 1,000 years. This is, all right, so all right. The black bar means like they had 43 places where they said how long a plastic cup would last. And some of them said like 1 year, and some of them said forever. And then the mean values is 1,000 years. So you have to take it with a grain of sand. I mean, definitely have seen styrofoam cups that have degraded in the environment. So this forever thing isn't true. And they do degrade in the environment. So, and the same with the PET bottles. So, and I haven't been around 700 years, believe it or not. So it's like, definitely some of these things are degrading. So I'm not sure exactly how much you can believe of these things, but they do last like a significant length of time, I mean, some of these things would be like for nuclear waste, like nuclear waste is forever, essentially, millions of years. Plastic bag is 150, 250. Start like if you look at these numbers, like if you take them for reality, then you have to kind of look at what you're doing, like and thinking like, do I really want to use that styrofoam cup? Yeah, because like if you think 1,000 years, like that's a pretty serious thing, and that's a number of generations. Put it that way. They're gonna have to be dealing with that same styrofoam cup. Do you really want to saddle those people in the future with that? Who might not even look human by that point in 1,000 years after evolution, I mean, who knows what it will be like. Plastic straw looks pretty good though at 250. So anyway, so it is kind of shocking if you look at that. This is one of the plots. There's a number of these plots. This isn't the best one actually, but you can see it's basically, this is an exponential growth curve. Like things are getting worse. It goes up to 2019. Oh, and then I have one that I didn't put in here that shows like projections for if we do nothing, this thing continues up. This is millions of tons kind of that have been produced that are living off that life cycle. So they're all still here, right? So, and then, but there are different scenarios of like, if we do reuse, the green part is bioplastics, which are degradable, right? So it's nothing. So anyway, and it's basically still nothing, but, and then, I mean, interesting thing is that like, that could be a large chunk of this and it economically could work. So Procter & Gamble developed this polyhydroxybutyrate polymer. It's a polyester like PET. And they were able to make diapers with it. All the components of a disposable diaper could be made out of biodegradable plastic. are quote unquote biodegradable. There's some debate over how degradable, right? But anyway, so they developed the entire technology to make they made the diapers, you know, and they scaled it so it could go into their factories. And then they got a new CEO and he like sold the entire chunk of that business, like to a Japanese company. Like they just gave it away, all the patents and the people, like the researchers that were doing it were sold with the deal. Like they took the whole thing and moved it to Japan. And then they have a plant now in Alabama that's making this Nodex polyoxybutyrate they could use. So they made bottles with it. They made all the things you make polyethylene. Anyway, so it's partly like it's kind of questionable, like, and they could do it economically. They had purchased land like in Kansas to grow soybean because they could genetically engineer soybeans to produce this plastic. So they had purchased all this land to make like commercially made bioplastic to replace the stuff. But it turned out it was just in case, like just in case like people got so pissed off that they had to do that. Like the writing was kind of on the wall. They had to go that route. Then suddenly it wasn't anymore and they just lopped it off. You know? So I'm trying to get someone from P&G to come out and talk to you. So far I haven't gotten anyone, but anyway, so that's kind of anyway, all right. And then the year after they did that, the CEO said, why aren't we doing anything in bioplastics? Like they didn't even know, in other words, it was just a Wall Street transfer to them. Like they didn't even know what they had done. Like then they read a newspaper article like bioplastics are big, and they're like, well, why don't we invest in this? It's like they had just sold off the largest effort in the US on it, you know, so like the largest, I think. But so anyway, it's kind of interesting how this whole it's really a weird game, and it's got partly to do with like it's got to do with a lot of different things, you know, so it isn't so simple. Like, so it's good to read the fluff books because they try to explain like what it has to do with. It has to do with us. Like, yeah, we're wasteful. We could do better. It has to do with just like the system, right? It has to do with like capitalism. Like people want to make money. So if you look at something like this, right? So this is reusable, like costs $5.50. And then it fills with these things, it costs $3.63 each, right? And then, but if you want to buy this thing, which is single use, right? That's linear, this is kind of circular. Those are $2.95 each. So like, why would you buy this thing for $3.63 for a refill when you get that thing for $2.95 and toss it, not have this clunky thing on your desk, unless you like the clunky thing, right? The clunky thing, by the way, is recyclable. It's a 7.2 plastic. It's ABS, can be recycled into park benches, right? Whereas this thing, polystyrene, is not, number 6 is not recyclable. So they're even making, they could have made that out of polypropylene, which would be recyclable, and they make it out of polystyrene because it's clear. So it's like, a lot of these things could be fixed, you know, if you wanted to. But basically all you care about is the $2.95. That's the bottom line. You go into the store, I'm not getting that thing, it's clunky. These are cheap. Like most people, everybody, you know, is just buying that. So the question is like, what's the problem here? Well, it's capitalism, you know, it's you, it's like, it's everything, you know, it's the history of how we do stuff. So anyway, so it isn't like so it's important to get this fluff end of it because it tells you like, it kind of tells you like it isn't such a simple problem to deal with, but there is like huge progress being made. And especially in the commercial end, like the businesses are like really motivated to kind of do things about this for a variety of reasons. One thing, they can't sell stuff in Europe. One thing is like they're going to use it as an advertising thing, say like we're better than the other guy because we're like not dumping stuff in the Pacific Ocean. And anyway, so there's a huge amount of motivations going on, and things. Some of them are honest drivers, and some of them are like just lip service, right? So it's tough to sift through what's what actually, but it's good to kind of read about it and develop your own opinion about where things are going and what's, you know. Anyway, so this is like a picture, a little bit of like what's so for polyolefins, right? So you start with oil. So it turns out like most of the ethylene and propylene monomers, which are 80% of the plastic waste, right? So come from, so you take oil and you distill it, and then you get kerosene as one of the cuts on the distillation column. Kerosene can be used as a fuel, so it'd be like diesel or jet fuel, or you can take it and crack it. When you crack it, which means just heating it up in a tank with some catalyst, I think it's like iron catalyst or something, then you just make olefin monomers from that. And then you fractionate those with pressure. So you just pressurize it, and I think the propylene comes out first or something, ethylene comes out later, right? So you don't even need heat or anything to do that. Then you take that stuff, those monomers, and put them into a pipe. And you ship it all over the United States, like in the US. So there's a piping system that goes from like Texas to Chicago. And then Lyondell has a huge plant outside Chicago where they make some like 50% of the polyethylene the US uses. And so there's no refinery near, and there is a refinery in Gary, Indiana, but they're getting their ethylene from Texas because Lyondell's a Texas company. Right? It's a petrochemical, like petroleum company. So they have wells and things. Like they're not just anyway. So basically, there's a system set up for this. Then there's also the flare, like the flare from the oil wells, the top that comes out an oil well, which is in the third world, it's burned, like they torch it. So you fly over like Angola, and like it's all oil wells burning at night off the coast, you know. So they just flare all the ethylene, which could have been made into polyethylene. And then on the land, they take that flare gas sometimes and pipe it into the system. So it's like an economy based. There's a piping company, there's an oil drilling company, there's a petrochemical refining company. All of them are feeding into the same ethylene gas pipes that go to some place to polymerize polyethylene. Could be like 2,000 miles away. And then it's metered. It's like the gas at your house, like it's metered. So you take out of the pipe and you put into the pipe. And the reason the pipes are a separate company is because they blow up. It's like the liability issue. Like Dow Chemical doesn't want to own ethylene pipes because the liability is huge. Like you could blow up a town like Palestine, Ohio, you know. Basically, those pipes are just as dangerous. So basically, to get rid of the liability, they have these small companies that take it. That's how capitalism works, you know. It's not pretty. I mean, it's kind of like there's a lot of little things going on. So you need some regulation to control it. But basically, the system we have is the best in the world. Like it's no place like Saudi Arabia, these places are all importing polyethylene from the US, you know. It's like all these Nigeria. Okay, what is it really? So where was it that this happened? Oh, okay. Okay, well, it's good you're here. All right, I acknowledge. So anyway, US, I mean, it's a huge advantage that the US has, you know, so we're like the #1 producer of polymers in the US, you know, because of that. So then the idea is like you can feed the recycling things, like you can regrind the pellets and then cut the virgin pellets with this recycled pellets. Then you can sell it as a 25% recycle stream, right? And then that can be used almost like the virgin stuff. You can depolymerize. This is only good for PET right now, but there's schemes of trying to do this using platinum catalyst with the olefins. And then you can just take the plastic and put it into a big oven and pressurize it and heat it up to like 400 C, and then it turns into oil. Like you can just cook it until you make oil. So you lose some of it when you do that, but basically you could take that oil from pyrolysis, just feed it back into the front end and crack it and make the monomers. So this, and people are doing all these things. Like this pyrolysis thing is big in Japan. Like they're doing that to make oil. It feeds into the oil system. Most of that is being used as diesel fuel right now. But the idea is like you could use that to make monomer again, and then it would be a cyclic economy if you did that, if you didn't burn it. Right. So anyway, so there's a variety of different ways to kind of go about this. This is kind of a schematic of the PET, grind up the water bottles. So ethylene glycol is ethylene, like 2 carbons and 2 H groups. and the PET has a carboxylic acid at the end, so that when they get together, water comes off. So it's a condensation reaction. So you get rid of the water and then it's a polymer chain. So it's a pretty simple thing. You can also, because it's so simple, you can also heat it up with water and it'll break the thing. So you can re-add the water and break the polymer down to make the monomer. That's the depolymerization of esters, right? So it's possible to polymerize and then reverse that polymerization if you add heat and water. You can split the ester bonds in a water bottle. So, and you saw like in the plot, it said that will last 1,000 years, but in the environment, some of that deesterification happens just in the environment. So polyesters aren't that stable. So if you just heat them up, they'll start breaking down. So it's hard to say where the 1,000 years comes from. Also, there's like fungi and things that eat plastics, and people are researching that, like how you can make like bioreactors to get rid of petrochemical. But when you do that, you're going to get like terephthalic acid, or if you do polycarbonate, you get cyanide. So it's kind of like, so you got to like wonder, it isn't just like I can degrade this stuff. It's like the plastic I have is absolutely inert. Like polyethylene is high molecular weight wax. So no one's worried about the wax problem. Basically they're worried about the polyethylene problem, but it's not going to do anything to anybody. Like wax has been around a long time, right? So anyway, but when you depolymerize it, the monomers might be a lot worse, more toxic. And even if you biodegrade, you still got to worry about like what exactly you're making from it, because some of the things aren't very good. Like polycarbonate's a prime example, but there's other kind of things that come out, and the additives are bad too. So depolymerizing might not be the best route to things. Anyway, they kind of filter the stuff and then condition it, and they polymerize it in solid. So they liquid polymerize. So they're doing condensation reaction to different extents, and they finally get to the high molecular weight that they want, and they pelletize it and make the resin and ship it. So that process exists. That exists in Tennessee. It's been around since like at least the 80s, and again, it went out of business because it wasn't economic. This is showing this kind of pyrolysis thing, which is just dump the plastic, and you put any kind of plastic in and you just heat it up. Then you're going to get some residue from it, and you're going to get some petrochemical kind of oil from it. So that process exists. So there's also this issue about plastics and the greenhouse gas stuff, right? So I mean, you can do calculations to figure out like 2/3 of greenhouse gases come from the linear economy, say. So people are constantly doing studies, figuring out like how bad things are. This is from that book, Take, Make, Waste. It's another like slogan of the fluffy end of the stuff. So, so there is a cost. So a good example of the cost is this idea of this. So so this is like how capitalism works. You have people go find oil in Colorado, and then they pump it, and then they make a bunch of money off that, and then they sell the oil well when it's down to the last kind of few gallons are going to come out of the oil well, and some other company buys it that doesn't have any money, right? So basically, they're selling the liability of that oil well. Then those oil wells have to be decommissioned. Like they can't just sit there because it's still like releasing gas and stuff, right? So they have to like concrete the hole and stuff. There's different things they do. Basically, decommissioning costs money. So they're finding out, because the Colorado wells are reaching the end of their maturity, that they have like 27,000 oil wells owned by these fly-by-night companies that have bought them at a bargain price, and then they're going to go bankrupt, and then like the people in Colorado or the federal government's going to have to pay to put concrete into them and seal them off environmentally, right? So basically the same thing is, so the idea here is that this is a linear economy. It's like you make as much money as you can up front, and then you just get out of the business as fast as you can, or dump the stuff somewhere and someone else takes care of the problem. So that's the whole problem with everything, right? That's the problem with plastics too. It's like the single use, the person that pays, like the person that pays in the end is you. Like you're gonna have to pay for it somehow, either by taxes, because the thing is still a problem there, and everyone that made money is gone. They're long gone, and there's no legal link to them anymore because they sold it legally to someone else who's broke. Right. So it's kind of a funny, this is just continually through our society, like how things work, right? So circular versus single use, like who pays for it? Let's see, who was that? Who pays for it is like, it seems like we pay for it in the end, let's see. So basically the line of single use thing is here. Anyway, I'm saying that, like, so who's to blame in that? Well, we encourage people to have businesses, right? So we're happy. So basically society is kind of to blame in a sense, the people that made the money are kind of to blame. Politicians who took money from the people that were making money are kind of to blame. People that invested in the stock market are partly to blame. Part of the blame is that like we got too many people and we keep making more. So we have like exponential population growth on Earth that are, all of those people want to have cars and they want to have everything that's going to make more of this linear economy thing producing garbage, right? So anyway, part of it is just overpopulation. And then probably a huge amount of it is just overpopulation, which isn't really anybody's fault, right? So, and then wasteful consumption is definitely a part of it. Unwholesome living is kind of a part of it somehow, So basically, the solution probably involves all those people and all the systems somehow, right? And it already is being solved, It's like there are people addressing this issue, so it isn't like it's being ignored, but it's kind of an odd thing when you look at it. And this is in that book, that like it's an odd thing. Like if you try to figure out a solution, you try to find out who's to blame for it. Anyway, so there's a lot of statistics, but like every year we're burning 1,000 years of biomass production, like for petrochemical, which can't keep up. Like we can't do that forever, right? So a lot of these things, it's just a matter of growing up for our society. Like you can't do that. That at some point you're going to run out of thousands of years, right? I mean, and basically we've reached the end of that, I think, pretty close to. Anyway, it's pretty hot out today, put it that way. So then let's see, what is this stuff? Yeah, it's similar. Like if you look at, so there's a problem though. Say we stop making polyolefins, like absolutely stop. So then if you're using oil to make polyolefins, and it's a byproduct of the petrochemical, you're still burning gas in cars, then basically we're gonna have a lot of ethylene propylene left over, which is toxic waste. Right. So you're not making the polymer, which is inert, you're going to end up with this huge pile of toxic waste that'll probably be burned. You probably just torch it, right? So, and the other thing, it's like similar to this problem, like original Dow Chemical was, they had salt mines in Michigan and they were going to make caustic from it. NaOH is like the most popular chemical after water. Okay, so, but when you make that from salt water, you end up with HCl, right? But you don't need much HCl in industry, you need a ton of NaOH. So it ends up, you have like a chlorine overload. So if you go to Louisiana, there's huge tanks of chlorine sitting along the Mississippi River, right? So it's kind of like you've been there. Yeah. So you got to wear a mask, or you carry a mask around with you in case the horn goes off. And you have 2 seconds of life before your body melts. Great place to visit. Yeah. So anyway, that's why we're chemical engineers. It's like, yeah, it's a thrill of it. Anyway, so anyway, you end up with a lot of chlorine. What do you do with it? So you're dumping it into PVC and chlorinated polyethylene, or like the garbage can for the chlorine. So if you get rid of plastics like PVC, all of a sudden you got a huge chlorine problem, like a huge chlorine problem. There's nothing you can do with it except acidify the entire environment or make like a kind of a chemical weapon from it or something. It's like, right? So basically, this is like an inner being of the whole eco-capitalist industrial system. You can't just pull out the plastic from it. It'll fall apart. Like, and there's going to be huge other problems showing up. So this isn't thought of very much. Like, basically, the system isn't just plastics, it's everything put together. And the plastics are like almost a dumping ground for a lot of problems from other industrial segments, like the chlorine and the ethylene and the propylene. So if you get rid of all those plastics, then you have to figure out what you're going to do with all this stuff now too. And in the stuff, the plastics are inert. So keep that in mind. They last 1,000 years. So basically, the other things aren't inert. Like the HCl will kill you. You know, even a small amount of it will kill you. So it's like, it's a dicey thing to think about, like what you're doing. Anyway, so anyway, you have to kind of look at the whole system before you start pulling levers on it. I think that's the bottom line of that. So this is something that's, I don't know, I found kind of interesting. So like if you buy a Tesla and it's like 65 kilowatt hour, and it can go 300 miles on a charge. The power in that is 2 gallons of gas. So gas is like an incredibly like energy intensive thing, you know? So it's insanely, so it's, I mean, this 65 kilowatt hour battery weighs a ton, like more than a ton, like a ton, 200 pounds or something, right? So basically you're talking about a ton versus whatever 2 gallons of gas weigh, like maybe 5 pounds or something, right? So it's basically, there's a huge energy density to this stuff. So that's why you can pump the stuff out of the ground, oil, and it's going to take, for every gallon of oil, you have to burn a gallon of oil to make the gas. It's basically, it's 50% off the start of wasted energy. And then once you, so if you just burn the oil, you would get twice the energy out of it. Then you make the gas, and then you have a, then you have a gas engine. So this electric car is going to 300 miles. It's 150 miles per gallon of the 2 gallons of energy that it used in that. And then this 150 is about 5 times the efficiency of a hybrid SUV. So if you take 50% by 5, you'll get 10% of the oil that you pumped. So 90% is just thrown away into the environment, and 10% is used, just straight up from, right? So it's kind of like, the whole system's pretty insane if you think about it. Like, why we're burning oil like that is basically because it's kind of like the crack cocaine of energy. Like, this stuff is like refined down to the point where it's so much energy density, it's insane, right? I mean, so anyway, it is a good, it's like it's like a great thing that we invented and we're able to produce this stuff. But basically, it's a huge waste. Like 95% is being dumped off for nothing. So that's why the EVs make so much sense. Like, all of a sudden, yeah, you could burn coal to power the EV, but I mean, this thing is 95% efficient, you know, the engine in it. So it's like, there's no comparison. Like, gas is insane to burn. It's totally insane to drive around a gas car. It's nuts, you know, like, anyway, just my opinion. But anyway, so whatever's in here, I'm not sure even why that's in there, except that that's my thing, you know. Anyway, so it's that business, and then you can, then there's this comparative pricing thing. So if you have, like, say you take the price of polyethylene, polypropylene, polystyrene, whatever, and then you have like a PET water bottle, it's got a polypropylene lid, you figure out it's like 10 cents to make that bottle. I mean, just from the prices of it, this is these are commercial prices, like if you buy a trainload of pellets. And a glass bottle costs 27 cents to make. An aluminum can is like cheaper than that, 7.5. So anyway, the price differences of those, if you're paying, you know, $3 for the soda or whatever it costs, like, it isn't that big of a deal. Like, you could use glass, you could use that, you could use that. So why is it that everything's made out of plastic? Like, that's a big question. Like, why isn't it made out of aluminum, which is cheaper, right? So it's transparent, like, it's nicer to look at, doesn't break, it's light. There's a few things that are useful for it, but that doesn't seem to really argue like why you're not, even glass makes sense, right? So there's something something about plastic. So what it is, if you take, like, say you want to make the Scotch tape container, well, like, there isn't a way to do that out of glass that's simple. Like, say you have an idea, you're going to make Scotch tape containers. Like, what do you do first? You make a 3D print of it, which is plastic. And then once you make that prototype and see that you get it right, you send it to this Quest Industries, and they make an injection molded part so you can see if it actually works on that scale up, right? Then after you do that, this entire economy is set up in China to mass produce plastic Scotch tape containers with the mold that you give them that's custom made. And then it's shipped to you like the next month, right? And then you can just sell it. Whereas if you're going to do it out of glass, it's going to be a lot longer process. And aluminum is even longer because you're going to have, like, you can't make a special Coca-Cola bottle shape out of aluminum. You know, it's always going to be that thing because it's pultruded out, like you pound out a chunk of aluminum. So you're stuck with one form factor for it, right? So nobody's going to do that. Like if you just start up a company, the stuff is going to be made out of plastic, right? I think that's a big part of why you see like this isn't really what the issue is. The issue is what you could do, like what you can actually technically do. Plastics are incredible. I mean, and also the whole economy is set up for plastics. Like we're tied to it, unless we want to figure out how to make aluminum cans in weird shapes that are clear, you know, or something like that, you know, which maybe you could do it, but basically somehow I think that's probably why like we end up with this thing versus that. You know, part of it is this system that we have already set up. And that can't really be changed very easily, you know. So anyway, this is an example of something that I ran into. I bought this vacuum cleaner for my daughter, 80 bucks on Amazon, right? And then after 10 months, there's like a little teeny piece of plastic on the front that messed up or got lost or something, so that it wouldn't, like, it would just go to the floor and suction down and you couldn't move it. Like it's totally useless, right? So I called the company up. They gladly sent me the money back, the 80 bucks, right? And then they said they didn't want the vacuum cleaner. You know, it's like, so basically it goes into the garbage. It's made of all plastic. Like there's very little in here that's made of metal. Like this is polypropylene, there's some polyethylene, that's PVC for the tube. If you figure it out, it's an entirely plastic. And this is polystyrene, the Eureka thing. Right, so the whole thing is just plastic. The wheels are made of polypropylene, like the whole thing is plastic. So this is like a solid waste disaster, right? That was 10 months of use. So I'm happy, you know, the company, so they make this in China. So I think they make this entire thing for $5. Otherwise, this wouldn't make any sense. Like, right? So this whole thing has to cost $5. I mean, labor is like almost free in China, right? And basically, they have the entire infrastructure to make these things in any shape and color that you want. Maybe $10 to ship it. I'm sure the shipping costs more than manufacturing. This business, me calling them up might be a couple bucks, right? So basically, their business plan is kind of like you call them up, like how many people are going to call up about it and how many are just going to toss it and buy another one for 80 bucks. I don't know. I mean, I would call them up, but a lot of people would just toss it. So the people that just toss it, like they're just making, so 80 minus $5 is quite a profit, right? So they're making a pretty good profit off this thing and they don't need to worry about it. It's a business plan, it works. Like this company's making money, right? I mean, I'm not making money, they are. So, I mean, I got the 80 bucks back, free vacuum cleaner for 10 months, but so it's kind of like, what's the problem here? Like, this is a problem. So reuse like would be totally viable here. Like if there was a fix-it shop that could put the plastic thing back in, something like that, but they don't even bother to do that. They don't care. So, because it's more of a hassle for them to pay a retirement for a fix-it guy or something. You know, so anyway, I showed this because it's kind of like an example of like, this is a linear system where something that would have been in the, like in the olden days, then you'd buy like a broom or something and it would be used forever. Like you'd think that that thing would be forever. And here's a thing that's a consumable, a thing that should have been a durable item becomes a consumable because of the economics of it, because they can make it in China for so cheap, etc. Like the whole system makes a durable item into a consumable item. And then that adds a huge amount to the solid waste problem, right? So I don't know how you fix that, but basically the system has grown. If you read that book or those two books, you realize that this goes back to at least the 1800s. Like how we've grown to the idea of, and he talks about, there were actually people, like business people in the 1950s that said, he quotes some people in the book that said, the business plan model is that we need to change durable items into consumable items. And that's the way that we can make money. Like there's like, take this vacuum cleaner, instead of it's going to last you 20, 30 years, it's going to last 10 months and toss it. And then like, that's what they want for everything. And then all of a sudden that's a way to make money off things, you know? Anyway, so another thing that's interesting that came up. Anyway, why don't I, let's see, it's 4:30. So I'm thinking like maybe go an hour, like instead of going an hour and whatever, you know, because otherwise it'll go on too long maybe. So why don't we, I can kind of end this here. So let's just try to go 1 hour. Then when speakers come in, maybe we'll go a little bit longer. So we can ask them questions and things. And then I'm going to try to go an hour every class, I think, you know, because otherwise we're getting like so late in the day and everything. All right, so I'll see you guys on Thursday. Yeah, what?
Hi. I was just curious about group formation, like will you?
It's on cameras. Yeah,
Okay.
it's already set up.
It's already set up,
Yeah,
okay,
yeah,
perfect.
so just, and the grabs are next to the end of
Okay.
that. So that's. So can you get to my website? Or?
Yes.
Okay. And then if you go down here, this circular, all right, this book, so you can click there. Oh, that's good, right at the top of that box.
Okay, I did not.
Yeah.
Which one it was.
Yeah, so
Okay,
there's,
now-
yeah, so there's books here, and also you can go into this, so I'm gonna pile all the books there. This so far is just this one, but then if you go into this down here, the files, then it's got all those files in there.
Okay.
So it's the same.
Thank you.
All right.
I was one of them. We are. Yeah.